Good afternoon, students. Today I am discussing about the measurement of mass. What is mass? We already know that the amount of matter present in an object is called its mass. So we can write the definition of mass like that. Mass is defined as the amount of matter present in an object present in an object. The amount of matter present in an object is called its mass. Now every particle in our world, every particle consists of some molecules and atoms. So every particles have mass. May be different, may be same, but every particle in our world have mass. We use the term mass in physics, but generally we use the word weight in everyday life to express the amount of matter. But when we measure, what is your weight? What is your weight? What is the weight of that particle? What is the weight of that object? That type we are asking that. Why? Because generally we use the term weight, but basically the amount of matter is called, the scientific name of that amount of matter is called mass. Clear? And what is the unit of that mass? Mainly the SI unit of mass is kilogram. We write like that, kilogram, and the symbol of kilogram is kg. And another CGS unit of mass is gram. You know that, and symbolized as small g. Another some multiple and submultiple units are milligram, hectogram, decagram, centigram, and as well as some submultiple units, that means smaller unit than kilogram are submultiple units are submultiple units of mass are hectogram, Hg, decagram, Dag, gram, decigram, Dg, centigram, Cg, milligram, mg. That's, and some multiple units, that means bigger than the kilogram, some units are there, some multiple units are bigger than kilogram are quintal. And we know that 1 quintal equal to 100 kilogram. And another multiple some units are metric ton. And 1 metric ton is near about 1000 kilogram. Okay, these are the some multiple unit. When we measure the heavy mass object, then we use this type of unit, quintal, metric ton. And when we use the smaller mass object, then we use this type of units, hectogram, decagram, decigram, centigram. When you measure the mass of small particle, small medicine, then we use milligram unit. But when we measure the bigger unit, like the production of the crops, total production of the crops in a village, or total production of the crops in a city or a town, in a state, then we use this type of unit, metric ton. When we measure the mass of a field lorry, then we use this type unit, quintal. Clear? Now, what are the main devices which we use to measure the mass? The main devices are, when we measure the mass, is beam balance. What is beam balance? I am showing you the image of that beam balance. You look that beam balance in every grocery shop. This is the image of beam balance, and which have two pans here and suspended two pans by a line rod, and this middle portion of the rod, there have a pointer. This rod is called beam, and there have two pans, and total this structure is called beam balance. We use the beam balance and as well as some standard weights also to measure some mass of any object by comparing this weight with that which we measure the object with using that unit. There have some standard weights, and one thing you must be note that the standard weight ratio of the standard weight is like 5:2:2:1. That is the ratio of the standard weights, by which the ratio of the standard weights, because by using this type of weights we can measure any weight. Because if we weigh the kilogram unit, we can measure 1 kilogram using this weight, we can measure 2 kilogram using this weight. When we want to measure the 3 kilogram, we add 2 kilogram and 1 kilogram, total 3 kilogram. When we want to measure the 4 kilogram, 2 plus 2, 4 kilogram. When we want to measure 5 kilogram, we use this unit, this weight. When we want to measure 6 kilogram, 5 plus 1. When we want to measure 7 kilogram, 5 plus 2. When we want to measure 8 kilogram, 5 plus 2 plus 1. 9 kilogram, 5 plus 2 plus 2. So we can measure, and 10 kilogram, that is also used as a 10 kilogram. Then 11, 12, all type of weights we can measure, all type of weight of any object we can measure using these standard weights. There have a beam balance as another device which is used to measure is called physical balance. And you look that physical balance in the gold shop. Basically they are used to measure small value of gold or any platinum or anything, and that's why they use this physical balance. And physical balance looks like evacuated with a glass chamber. This is the type of a beam, looks like a, this is called physical balance, which we basically used in mainly laboratory, and as well as very specific or accurate measurement. Due to accurate measurement they are used, or sensitive measurement they are used this physical balance. And another unit also used nowadays, that is called electronic weight machine. This looks like that. We all uses electronic weight machine to measure any masses. Clear? Now what is the main features which a accurate beam balance have? Main features of the accurate beam balance are: both the pans must be equal masses. Both the pans must be equal masses. I am showing you this beam balance also. Again, this is the image of beam balance. So both the pans, this pan and this pan, must be with equal masses. Okay. Second, both the pans must be equal masses. First one. Second one is both the arms. That means this is called right arm. This is called left arm. Both the arm, these two arm, both the arms must be of equal length. So this arm and this arm must be of equal length and uniform cross section. That means we take a similar type of rod and both the arm have equal length. Third one, both the pans must be suspended with string of equal length and masses. This string, both the string have equal masses and equal length. Otherwise, this pan will be kept at here and this pan will be loses at here. So we cannot measure the accurately. So when we want to measure any masses accurately, these 3 points and another one, when the pans are empty, the beam should be horizontal and the pointer is vertical. The beam should be horizontal means like that, and pointer should be up and down direction arrow. This is pointer which shows the up and down vertical position. Clear? So these are the 4 points must be maintained for any. These are the 4 points or features for a beam balance which measure the accurate measurement. Which can measure the accurate measurement. First one, both the pans must be of equal masses. Second one, both the arms must be of equal length. Third one, both the pans must be suspended with string which are equal length and masses. And fourth one is when the pans are empty, if we hold this beam balance, then this beam balance should be horizontal in plane, horizontal with in this beam balance, beam of that beam balance should be in horizontal line and must be pointer should be in vertical line. These are the 4 features of any accurate beam balance. And there are when we measure the small masses, we basically use physical balance. This also have for accurate measurement we use physical balance, as well as nowadays we also use electronic weight machine also. Clear? Thank you student. Thank you very much.